Okay. Alright. Oh, sorry, John. It's early in the morning for me here. Um, I'm going to do a problem like the one that you see in question 14, that tension problem. And so, let's say that I have a billboard and it's being hung from two posts. And let's say this angle is, oh, I don't know. Let's say it's 70 degrees. And this angle up here is 45 degrees. And the billboard weighs 500 newtons. The thing that you have to know is that any vector can be broken into components, which means I can take any vector, I'm going to change the color here, and I can break it up into its x and y parts. So that's its I hat part, and that's its j hat part. Another way of saying this is like saying that this is its x part and this is its y part. And so if I'm going to call this vector, let's call it f1, and I'm going to call this vector f2. And I can take the other vector and I can do the same thing to it. I can say that that's its I hat and this is its j hat, which is like saying that this is its x part and that's its y part. The angle that is the most important is not that one, it's this one. It's the one that's from the x direction. So if this is a 90-degree angle, then this angle would be 20 degrees, and that angle would be 45 degrees. And so I'm going to take both of those vectors and break them up. So f1x would be equal to negative f1 cosine of 45 degrees. f2x would be equal to f2 cosine of 20 degrees. I'm going to do the exact same thing to the y part. f1y would be equal to f1 sine of 20 degrees and f2y would be equal to f2 sine of, I'm sorry, this is 20 degrees, this is 45. Because this vector, the green one, and the red vector are in opposite directions, they cancel each other out. So you can say that those two parts are equal to one another. So f1x is equal to f2x. Because in order for this thing to be stable, those two vectors have to be exactly the same. And then I know that f2y and f1y both have to be, they have to add up because they're both pointed up, and it has to equal this vector going down because that's how all of the weight is being supported. So your other equation would be f1y plus f2y is equal to 500 newtons. And now you have a system of two equations. So let's plug everything in. So I'm going to say that, I'm going to need more space. Well, let me just write the system here. So I'm going to say that I'm going to say that f1 cosine of 45 is equal to f2 let's see, can I move this over? No. Okay. Again, I apologize. I'm like half asleep right now. Let me just erase here. Give myself some space. Alright. So now let me write my system of equations. Ooh, Lord Jesus. Okay. Alright. So we have f1 cosine of 45 degrees is equal to f2 cosine of 20 degrees. And then we have f1 sine of 45 plus f2 cosine of 20 is equal to 500. And so you solve the top equation for f1 and then you substitute that in to this equation, so all you have is f2, and then you solve this equation for f2, and then once you have f2, substitute back in. It's like a system of two equations. So that's how you're going to have to do the question that you actually have. I hope that was clear. Try to follow the steps. If you still have a problem, then give me a call and I'll walk you through it again. All right, I'm going back to bed. See you later, John.